Fantastic. That it was. Next up, we're going to see Spencer Coile perform his informative speech. Spencer is a devoted member on our team and a freshman. Spencer placed second place at the National Comprehensive Tournament National Championship. So give it up for Spencer Coile and his informative.
Since the dawn of time, society has sought methods to get from point A to point B with ease. From the development of the wheel to Roman chariots, schooner sailing ships, planes, trains, automobiles, hover rats, monorails, and even the little red wagon, we have seemingly mastered all forms of transportation, except for perhaps the coolest of all. That is, until today. In 2010, Nobel Prize-winning biologist Dr. Luc Montagnier made a discovery that shook the scientific world and may reconceptualize transportation as we know it. The Journal of Quantum Physics, Winter 2011 reports that Shanghai Jiaotong University has reached ground zero for research in quantum teleportation. In a recent experiment conducted by Dr. Montagnier, a single-cell bacterium was finally teleported an inch. But hey, a small step for bacteria, but a giant leap towards proving teleportation is more than just a mere pseudoscience. The June 24th, 2011 edition of the Los Angeles Times claims, when this technology proves viable, the future of transportation will be forever changed. So today, we are going to explore the ins and outs of teleportation. By first, examining the already successful process of light teleportation, then recent attempts to teleport bacterial DNA, before finally looking at what this breakthrough might mean for our future. So first, let's consider quantum teleportation and how exactly it works. Beam me over there, Scotty. This research is being conducted by top research facilities, such as Harvard, the University of California, Berkeley, and the University of Maryland's Joint Quantum Institute, also known as the JQI, previously deemed impossible and undoable. Scientists at these facilities have not only experimented with the transferring of light particles, but they have done so successfully. According to CNN, on October 10, 2011, physicists have started working with the theory of quantum teleportation, which is the transmission of information rather than actual matter. Simply put, the theory involves two separated particles acting as though they were still one and the same. Any change made to one particle appears in the other. The October 10, 2011 New Scientist magazine states, "This is not teleportation as we'd like to think of it. Namely, an object disappears from one place and reappears in another. Rather, it is about the transferring across space properties of particles, and in particular, their spin. Using this process, researchers have been able to transport these particles quite a distance. When measured in terms of atoms, they were transported over 0.5 meters, and when measured in photons, over tens of kilometers. These experiments were continued in 2012. According to Time magazine, on January 29, 2012, the JQI conducted experiments in which two charged particles, place each in a vacuum and keep them in position with electric fields. Then, an ultra-fast laser would pulse trigger the atoms to emit photons simultaneously. Now, if the particles were to encounter each other and interact in the expected way, then their parent particles would begin to enter a quantum state of entanglement, where the atoms would adopt the other's properties, even though they are in separate containers. Thus, teleportation has been achieved. With quantum teleportation as the foundation, let's now consider its ability to teleport bacterial DNA and the leading research in this field. But first, can I have you all close your eyes for a second? Okay. What do you know? I just teleported to my second point. If only it were that easy. Recently, Dr. Luc Montagnier has returned to the spotlight for his paper regarding an experiment of DNA teleportation. TechWorld, January 13th, 2011, describes the experiment as 2 test tubes, one of which contained a tiny piece of bacterial DNA, the other, pure water, were surrounded by a weak electromagnetic field of 7 Hertz. 18 hours later, and after DNA amplification using a polymerase chain reaction, the DNA sample was detected in the other test tube. This experiment is just the beginning, however. There is a possibility that this process had not been detected, because in order for it to work, the DNA sample had to be diluted many times over. It is also possible that this system, by definition, might not be considered teleportation, because rather than moving from place to place, the DNA sample already imprinted itself on the other test tube. Critics have begun to, well, criticize it, because according to the aforementioned TechWorld article, quantum occurrences happen only within fractions of a second, and usually at unbelievably low temperatures, generally approaching absolute zero. These experiments will have to be validated by many more scientists in the future, of course. But so far, it's the start to what could be one of the greatest scientific breakthroughs of this generation. With the breakthroughs in bacterial teleportation, let's now consider its twofold implications: the current challenges faced by this technology and the potential application. Now, don't expect to be the next Captain Kirk by shooting your atoms from one planet to another. Multiple scientists are already stating human teleportation is close to, if not completely impossible in the near future. On the Joint Quantum Institute's website, on January 13, 2012, JQI leader Christopher Monroe explains, "There are way too many atoms. At the other end of the transporter, there needs to be a blob of atoms that represents Captain Kirk, but has no information in it." I mean, what would that look like? In other words, for human teleportation to be feasible, there must be a vessel containing undesignated atoms for us to land safely in, because we have way too many atoms for every single part of us to be teleported successfully. This could mean, when in the act of teleportation, we could accidentally leave an arm, an eyebrow, or even an organ behind if not performed properly. An article from Forbes magazine on April 15, 2011 expands on this by introducing physicist Philippe Grandier of France's Institut d'Optique. Grandier describes how he believes that although scientists are working hard on DNA teleportation, a whole bacterium just seems out of the question for the time being. We are really learning to manage the quantum world, Grandier explains. This is an extremely long and painful process, especially for experimentalists like me. All of these things, just a few years ago, were just ideas. But now, they are turning into experimental realities. Interestingly enough, acclaimed science writer David Darling states in his 2005 book, Teleportation, The Impossible Leap, that no matter how we look at it, teleportation is in it to win it. He goes on to say, one way or another, teleportation is going to play a major role in all of our futures. One thing is certain, if that impossible leap turns out to be just merely difficult, then it will someday be accomplished. So today, we discussed quantum teleportation. We've seen how scientists have taken the first step through light teleportation, have gotten their foot in the door by teleporting bacterial DNA, before finally looking at what this breakthrough might mean for our future. With the potential of quantum teleportation growing every day, getting from point A to point B just got a whole lot easier. So roll on over, wheel, and beam me up.